Now, when you are programming in C#, you follow the object-oriented programming system, or OOPS for short. The OOPS paradigm is built around the concept of objects, hence the name. These objects contain some data in form of variables and ways to modify this species of data in form of methods. Now, before working with objects, you will first need to create an object, and you can do that using classes. You can think of classes as templates which can be used to create an object. Let's go to the RPG analogy so that I can give you some context. Think about the weapons in your game. Let's say at this moment you are thinking about swords and you want to implement swords in your game. So what you would do is think about the properties that every sword in your game will have in common. As you think about it, you will come up with a list of something like sword name, piercing damage, slashing damage, bleeding damage. Then let's say suppose it's an elemental sword, then elemental damage, mana consumption, then weapon HP and whatnot. Next, what you need to think about is what actions can be performed with or on your sword, either by your player or by a game mechanic that you made for your game. Again, when you think about it, you will come up with something like attack 1, attack 2, parry or defend, etc. Now with that we know what properties all the swords will have and what you can do with these swords in your game. So what we can do now is create a template which has these particular properties and actions and can be used to create the swords. This template that we are creating is what we call a class in the OOPS paradigm, and the properties and actions of the sword will be defined inside the sword class using variables and methods respectively. I hope that I was clear enough. Now let's say you want to spawn two swords in the player's inventory when the game starts. One of them is a rapier that is good at thrusting, while the second is a war sword which is good at slashing. To do this, we will use the sword template that we have created and make instances of this template. Creating instances is just a fancy way of saying that we'll be taking this template with these variables and make copies out of it, and these copies that we make are what we call objects in the OOPS paradigm. When creating a copy, we will also give every single copy a name, and then we'll fill in the data inside these copies based on the template that we have created. So in our case, we have a sword template with various variables, and we'll make two copies out of it. Then we will give each of them a unique name like Rapier 001 and Warsword 001. And after that, we'll fill in the variables with appropriate details. So as rapiers are good at thrusting, it will have high piercing damage, while as warswords are good at slashing, it will have high slashing damage. So to reaffirm, classes are blueprints for your objects. Basically in Unity, all your scripts will begin with a class declaration. Unity automatically puts this in the script for you when you create a new script. This automatically created class shares the same name as the C# file that it is in. This is very important as both of them should have the same name, and if you change the name for one, you need to change the name for the other. So try to name whatever scripts you make sensibly when you create them. Moving forward, one of the principles of OOPS is to split your larger scripts that do a lot of different things into multiple scripts that each take a single role or responsibility and therefore be dedicated ideally to a single task. The main aim of object-oriented programming is to allow programmers to develop softwares in modules, and this is accomplished through classes and objects. With that explained, let's go to Unity and create a script named template_sword. Now let's open it in VS Code. As you can see, Unity automatically generated some code inside the script, and here we have the class name, which is the same as the name that we gave to our C# script. Now let's declare some private variables based on what we thought before about the common properties between multiple swords, like _sword name, _piercing damage, _slashing damage, _bleeding damage, _elemental damage, _mana consumption, and _weapon HP. I'm prefixing the variable name with an underscore to differentiate between private variables and other type of variables. Doing this is quite common, and if you are looking at other people's code base, you will see this a lot. With these variables declared, now let's declare the actions that can be performed using a sword with methods. So with that, we have created a new script named template_sword from scratch, and then inside that script, we have an automatically generated template_sword class with the necessary variables and methods. Now let's go to the start method and create a rapier and a war sword by creating two instances of the template underscore sword class. So to do this, we have to first type the name of the class, which in our case is template underscore sword. And after that, we have to give this variable a name, which I'll be giving rapier001. Then we have equal to, and after that, we have to type new and then template underscore sword, but this time with opening and closing parentheses after it. With this statement, we have created an instance of template underscore sword class. That is, we have created an object with the name rapier001. Now let's create another instance named warsword001 below it. So with that, we have used the template underscore sword class and instantiated two objects of that class. Now before moving forward and adding data to these two objects, I need to explain some things. First is that each object that you create will have its own copy of variables that we have defined in its class. So if we change the value of bleeding damage variable in rapier001, it will have no effect on the value of the bleeding damage variable in warsword001. Second, the methods that we have defined inside the class are shared between all the objects of that class. Objects do not have copies of these methods. Now some of you might be thinking, wouldn't sharing the methods between objects make the code ambiguous when we try to access a variable inside the method's code block like this? But as you can see, we didn't get any compile time errors, so the code is fine. The reason why this is not a problem is that any variable that you are accessing from within a method using an instance of a class refers to that variable of that particular instance. This is why even though methods are shared between all the instances of that class, they are not ambiguous. With that explained, now let's add some data to these two objects. To do this, we'll type the name of the object like this, and then dot, and then the name of the variable that we have defined inside the class. So in this case, underscore sword name like this. After that, we have equal to, and then the value we want to set to this variable. That's it. Now let's quickly set all the variables for both the swords and then debug.log all the variables of both these objects like this. With that done, now let's make a call to the attack method from warsword001 object. To do this, we'll type warsword001, then dot, and after that we'll have the method name and the two parentheses like this. This is all you need to do to call a parameterless method. If your different method has parameters, then you will pass arguments to these set parameters between the parentheses as I've shown in the video about methods. I'll link that video in the description and in the YouTube cards for those who want to reference it. Now let's make one more method call, but this time to the parry method from rapier001 instead, like this. With that done, now let's go to Unity and check the logs. As you can see in the first two logs, the values were set as expected, and in the last two logs, we can see that warsword001 attacked while rapier001 parried that attack. So everything is working as we intended. Back to the code, now let's talk about instance variables and instance method versus class variables and class methods. So when you declare a variable inside a class like this, what you are doing is you are declaring an instance variable. Every time you create an instance of class, it will create a copy of this instance variables for the new instance. While when a class variable is declared, the runtime system allocates class variables only once per class, regardless of the number of instances created of that class. The system allocates memory for the class variables the first time it encounters the class. All the instances of the class will share the same copy of the class's class variables. Methods are similar, that is, you can declare instance methods and class methods. Instance methods can operate on the current object's instance variables, and they can also have access to class variables. Class methods, on the other hand, can only access class variables and cannot access instance variables declared within the class unless you create a new object or pass an object as an argument to the class method and then access the instance variable through this object. By default, a member declared within a class is an instance member. To declare a class variable or class method, you can use the static modifier when defining them. Also, you don't need an instance to call a class method. To show how to use static modifier within the code, let's make _sword name a class variable instead of an instance variable like this. And as you can see, we got a couple of red underlines. This is because as now _sword name is a class variable, you can't access it like you would an instance variable. Instead, you can access it directly by removing the object name and dot before it like this. And as you can see, the red underlines are now gone. But now if you go into Unity and check the logs, both the swords will have the same name, that is warsword001, as there is a single copy of _sword name class variable that is being shared between these two objects. So let's go to Unity and check the logs. As you can see, both the swords have the same name, while the other variables were set the same as before. Back to the code. Now let's make the attack method into a class method instead of an instance method. And as you can see, we got a red underline beneath warsword001. This is because we are again trying to call a class method like an instance method. So if we remove warsword001 dot like this, then the error is gone. Now let's move on and talk about constructors. A constructor is a special type of method that is called whenever an instance of class is created. Unlike normal methods that you can name whatever you want, the name of the constructor must match the name of the class, and it cannot have a return type like void, int, etc. All classes have constructors by default. If you do not create a constructor yourself, C# creates one for you automatically. So to define a constructor, all you need is the access modifier and the constructor name, which is the class name. After that, we have the two parentheses and the code block. Now, as you can see here, after we create an instance of the template _sword class, we are assigning values to it in the start method. All this code can be moved to the constructor's code block, and then whenever a new instance will be created, the constructor will be called automatically. Now, to make this code work inside the constructor, we need to pass some parameters inside it like this. And then in whichever places we are creating an instance of template _sword class, we can pass arguments directly inside the parentheses like this. What this does is it moves all the clutter that we had in the start method to the constructor, and as we'll reuse the code inside the constructor, the lines of the code will directly be halved, as you can see here. Also, we cannot call a constructor like a method. If we try to do it, we'll get a compile time error like this. So let's remove this and modify the debug.log inside the constructor like this. Now let's go to Unity and check the logs. As you can see, the constructor was called and the data that we passed as the argument was set as we intended. Well folks, that does it for today's video. Hit that like button and subscribe to the channel if you like the content. Do comment below if you have any doubts or if you just want to share your thoughts. And as always, if you see someone struggling down in the comment section, do try and help them. Goodbye for now. This is your host VP signing off.